Hello, and welcome to another episode of Hacking with Friends. Today we have my sometimes co-host and Michael number 4, Nick, who is also the host of the Null Byte YouTube channel. Nick, thank you for joining us today.
Yeah, thanks for having me on again. It's been a while since I've been here, but I'm always excited to come on and talk about nerd stuff.
Cool. Well, today I decided that it would be awesome to have you go into some more stuff around Android Studio, because we've had a lot of people ask about Android hacking, and frankly, this is the safest and most ethical way for anybody who wants to learn about cell phone hacking to get started. Because for one, it doesn't require much of an investment. You don't need to go out and buy a bunch of Android cell phones to experiment with different types. You're able to use an existing computer to do a lot of really interesting and cool stuff. And also, there's a community out there that has some great tools to allow you to learn about how vulnerable applications and other sorts of security issues you would expect to see on a cell phone work. So Nick can probably explain a little bit better than I, but can you explain a little bit about what Android Studio is and really like what it offers to beginners who want to get started with hacking?
So really at the end of the day, Android Studio it's an open source public tool made by Google, but it's primarily made for app developers. It's like most of its functionality is as like a programming IDE, giving you a space to work and make Android apps using Java. But in order to allow developers to test the apps they make using Android Studio, it comes in with a built-in Android device emulator. And so for free, you can just pick almost like any Google phone, so like a Pixel or even the older Nexus phones, and emulate it using almost any version of Android. And then but there is it looks exactly like my Pixel 2 XL right here.
Let's switch over to Nick's screen real quick.
Yeah.
There we go.
Yeah, so like I was saying, Android Studio allows you to create these virtual Android devices in order to play with them. And so like ideally, or what Google has in mind is that you're going to make your app, you're going to load it easily onto your phone, and it gives you like the perfect debugging environment to test your app. But if you're not super interested in making apps, you can also use this to test Android exploiting and do Android pen testing. Because for one, you're definitely not going to want to test like exploits against your own phone, because that's stupid, and there's a lot of like very, very private information on my phone. I don't want to make that. I want to make my phone as secure as possible, and I don't want to test exploits against it. And two, hacking Android, it's a little more difficult because it's like when you're like doing pen testing on a computer, you can do pen testing on a virtual machine or like something like Metasploitable, and it's easier to make like a partition of your computer that's safe to test exploits on. That's much more difficult on Android, and you don't want to just buy a new Android phone just to do exploits on when there's a free alternative available with Android Studio. And this is like, it's almost as if there was a real, it's on 100% emulating a real Android device being plugged in via USB to my laptop. It's interacting with it in the exact same way. So it's the perfect way to not only like learn some command line tools related to Android, but do some basic Android exploiting and pen testing.
Interesting. So this is creating is it creating like a virtual machine that's basically running Android and presenting itself with like a little built-in interface to allow you to install apps and stuff?
Yeah. So when you go to, so like first of all, like when you interact with this like the same way you would interact with a normal phone, like it's like it has a touch screen, so it interacts almost one-to-one. And second, we showed this off the last time I was on the live stream, but that was a while ago now. But if you go to the Android Studio, this is the AVD Manager or the Android Virtual Device Manager. When you create a new device, you even have the option to create a device that comes with the Google Play Store pre-installed.
Interesting.
So the benefits of this is like I can just if my device had the Google Play Store installed, I could just like load WhatsApp onto this and poke around WhatsApp and see if there's anything I can get going with that.
Okay, so I had a question about that. Like, so you say you can install apps, you can use them just as though it's on the real phone, right?
Yeah. Yep.
So, well, for one, I have a question. Do you have a VPN on?
I do. I do have a VPN.
Interesting. Do you think, is it possible to open the browser and just navigate to a website?
Yeah, I should be able to.
So I'm just curious, like, what does it look like if you were trying to like cover your tracks or disguise who you are? Like, a lot of people ask me about how to hide your user agent. Can you go to www.crimes.gay?
Oh, I googled it because this is Android.
Yeah, www.crimes.gay.
Crimes. See, it takes me to Google first. It's so weird.
You can also just type crimes.gay. I think that will work too, perhaps.
I know, it's just weird because it's Chrome on Android, so it's like taking me to Google first because it thinks I'm a child. Yeah, it thinks I'm a child.
Interesting. So you literally just like can't go to certain websites on that.
I think I should be able to. I don't know why it's taking me through Google first. What if we go to the desktop site? I'd have to install.
Is there a space? Is there a space at all? Because it's a web URL, so.
No, there's no spaces. Is it HTTP?
Yeah, try that. www.crimes.gay. Does that work?
Yep, there we go.
Whoa, that took a lot of effort. Okay, so you've just gone to the honeypot, and hey, all right, let's switch over to my screen for a second. So this is my tracker that I use to like just demonstrate. Like, Michael, go to my screen. Sorry, Michael was taking a nap. Okay, sorry. So this is my like little honeypot I used to demonstrate like user agent tracking and stuff like that. And you can see that Nick is living it up in sunny Las Vegas. How is it?
It's hot and it's not rain. It's definitely not raining like it is in California right now.
Ah, interesting. Well, that's too bad.
Yeah,
so,
and I can legally gamble right now. So.
So I can see this says that the browser is Chrome and the operating system is Linux. It has a specific version number. It has the Linux platform. We can see different things about things that are. We can see the vendor's Google as well. So that pretty definitively identifies this as an Android device. And we can see here the user agent says Mozilla, Linux, Apple WebKit, like Gecko, Chrome, blah, blah, blah. And that's basically just your browser trying to be low key and not give away the fact that it's an Android phone completely. But it kind of does that with the vendor being Google Inc. Mm-hmm. So here, like when you open this website, it basically made the request as though it was coming from an Android phone. And that's exactly what this is designed to emulate, the complete experience of doing stuff. So even if someone's doing like URL tracking or like watching the stuff that's coming out of this, it looks like an Android phone, which I think is super cool. So sorry, I just wanted to spy on that a little bit and see what it looked like when you do something from the phone, if it looks like it's from an Android device or if it looks like it's from your computer. And obviously, are you running Windows or what are you running?
Yeah, this is on top of Windows.
Okay, yeah, so clearly it had no idea you were running Windows. It sincerely thought that this was a Linux device. And really, since it's an emulated one, that's a pretty accurate assessment. So kind of a cool thing for people that are talking about like wanting to get around like user agents and stuff. If you want to try something that only has an Android app or an Android interface or only works on mobile, this is a great way to do it.
Yeah, and it's like another, I never thought of it until just now, but it's like another interesting like layer of obfuscation that you can add to anything you want to do on the internet.
Right, you could just spin up like a fake Android device, do a bunch of stuff on it, and then delete it, and then spin up a new one. So it's really interesting to have that like kind of almost like burner device you can spin up or shut down just by creating a virtual one.
Yes, yeah, and the only thing is AndroidStudio emulating a device is a little bit resource intensive. So as long as you got like a decent laptop, it should be able to run just fine. But just it's important to know, like on lower end machines, it's just going to bring your machine to a halt. But if you can run like an Ubuntu VM or whatever kind of VM, then you should have no problem running a virtual Android device.
Cool. All right, so we've showed off that it can basically run like a normal Android device. And to anybody that's been on our stream a lot, you probably know that we've covered Android Studio with Nick before. And this is going to go hopefully a little bit deeper and show off some of the things you can do, not just to set up an Android device, but also attack it. And the really cool thing here is that just the same way there's like a vulnerable Raspberry Pi image for people who want to study attacking a Raspberry Pi, there's also vulnerable Android applications that can be loaded that allow you to study the way that attackers will actually go after these sorts of apps and start to target Android devices.
Yes. So last time we briefly talked about how to install this app called Diva, which stands for Damn Insecure and Vulnerable App. It's made by this Indian cybersecurity company, I believe. And it's analogous to Metasploitable, if you're familiar with that. Whereas like Metasploitable will create, it's almost an exploitable operating system. This is an exploitable app that's built that can be run onto an Android.
Okay, so this is not like you're not creating an Android image that's vulnerable at its core. You are creating an application running on Android that is vulnerable.
Yes, yeah. So today we're mostly going to be exploring how you can poke around into like apps and look at their source code and discover any potential vulnerabilities that app may have with like storing data and stuff like that. And Diva is like the perfect testing ground to get started with it.
Cool. And again, this is great for people who want to get into like bug bounties or start making money on the side by accepting bug bounties for like applications or other things that really want to find out about these vulnerabilities. If you wanted to start exploring them, then the same way that you would start poking around with this demonstration one, you would load up the app in a virtual instance and you would start poking around with it and seeing if you could make it do anything weird. So I think that it's just cool that this is actually a way that you guys can like learn to use a skill that can make you money as you're starting your career with hacking. Because if you get involved with somebody who does bug bounties, like let's say Bugcrowd or Hackeroni, then you can actually make cash on this, and it can be a viable side job and a skill that's really valuable to learn.
Yeah, and it just helps the community. If you're the one finding the bugs and you're reporting it immediately, that's just a more secure internet, and it's a good thing to do. You're making money, and it's just like a morally good thing to do.
Yeah, cool. So, all right, I really like the fact that if anybody's just getting started, we're providing them with a perfectly legitimate target to start out with. So if anybody's, going to try to use these skills for evil, we can say at least, hey, look, we gave everybody at least the option to do this on pretty much any computer that has enough resources to create one of these virtual devices. And it's completely legal. You can hack it as much as you want, and no one is ever going to get mad at you because it's your virtual copy of Android. No one's going to sue you. So that's makes teaching this sort of stuff a lot easier.
Yes, definitely, and it's free, assuming that you get enough laptop. It's completely free. You don't have to buy a actual physical Android device.
Does it matter if your laptop folds?
If it is a laptop, the folding is a very desirable aspect of that. So I would say yes, it does matter for laptop.
You heard it here first. Nick, really big in favor of the first folding laptop. All right, cool. Thanks for coming out in support of that.
Yeah. Someone had to. You gotta be early adopter.
Yeah, sorry, Zam is trying to get me to check out a folding laptop for cybersecurity purposes, but it appears that it's only useful in space according to the marketing. So very sad. I was looking forward to using it.
One day I'll fall down. One of them will fall into Earth one day. Okay, so I guess really quickly we can start getting into Diva and actually show off some of the exploits. Does that sound good?
Yeah, that sounds great.
Cool. So last time I showed how we actually installed Diva, but I can go over it super briefly because it's actually a very easy process. Once you get this Diva APK file installed, you can open up a command prompt and we can type in ADB. And ADB is Android Debug Bridge. And this is a tool made by Google that is used to communicate with an Android phone over the command line. So it's obviously very useful on a computer. And then first, we got to make sure that the Android Debug Bridge can actually recognize our virtual device. So we can type in ADB TAC devices.
Could you enlarge it a little bit?
Yeah.
And by a little bit, I mean a whole lot.
Here, let me open Git Bash because I'm not sure how to zoom in on that one. There we go. Okay.
Perfect.
So, is that good?
Yeah, that's perfect.
Okay, ADB devices, and we can see that it is able to recognize our emulated Android device. And it's important to remember this key. And I already have Diva installed onto my virtual device, but the command to do it is a one-liner. So as long as you're in the same directory, which I don't think I am, you need to be on desktop. To install Diva, it's just ADB TAC S. TAC S install diva.apk or diva beta APK and then the name of the device, so emulator 5554. And I already have it installed. Easy. Yeah, and then it's as long as you have the APK right there, it's just that one line and it'll work.
So basically what you're doing is you're, via command line, installing an application onto the Android device.
Yes, because so like I was talking about earlier about how you can use virtual Android devices that come with the Google Play Store. It's convenient because the Google Play Store is right there, and you can just use the phone's interface to install apps. It is slightly more annoying because you'll then have to root that device. You'll have to root that device manually if it comes with the Play Store. Whereas if it doesn't come with the Play Store, you'll have root access to the device by default. And that makes it a little easier to show off some of these exploits if the device is rooted. So this one does not have the Google Play Store, so you have to install all the apps using the command line, which isn't too difficult. So once the APK is installed, you can navigate using trackpad, so it's a little weird. We can pull down here, then go to settings, and we can see all of our apps. And Diva's right there, but you can, if it wasn't right there, you can go here, and then we can open it up. Right here. So this is the interface of Diva, and it comes with 13 different test cases. So last time we showed off insecure logging, which was basically if, for instance, an app asked you to input some kind of data and it came up with an error, that error usually wants to be logged so developers can go back and look at the error. But sometimes the error will include too much information, such as my credit card. So if you have Logcat going, it's scanning all of the devices that are all of the messages that are being logged by that device. And if the app happens to log something that it shouldn't, then you can find it here. But
did you just set yourself up to? Did you just set yourself up to look for the string 1234 in that giant mess?
Yeah, but
just type in big_private in all caps.
That's probably a better idea. Let me actually didn't close it too. Big.
Yeah, big_private. Oh no, it's just maybe it won't accept the input.
00000.
Yeah, there you go.
Oh, and I have to be actually logging while it happens. Oh, there it is. Oops, close. Diva log, which is the app. Error while processing transaction with credit card 00000. So obviously the developer will want to see all this information, but they definitely don't want to see what the user inputted. But yeah, it's very easy to misconfigure an app like that, and this is a very simple case.
So what is the primary threat there that a hacker might be able to find there? Are they identifying a threat that somebody with physical access to the phone might be able to intercept it, or are they identifying that the developer might unintentionally be getting private information that the customer wasn't intending for them to get?
Definitely both, because if you notice, like this exploit didn't require the device to be rooted. So if I have some kind of physical access to your device, and this could be even over a network, and you inputted the device, this error message was displayed, and then if I was logging all your error messages, I'd be able to see this. And the same thing, it goes to the developers. They could also see it, and it's also bad, obviously.
Right,
so yeah,
right.
That's a good point.
Cool.
But that was our simple case that we went over last time. But now, so this one is called hard-coding issues, which should ring off some alarm bells that this probably has to do with a key that is stored directly in the source code. So in order to complete this challenge on Diva, it's asking us to enter a key. So if I guess a password like 123, it's saying, no, we failed with the kind of mean message. So you can't, in order to see the source code, we're going to have to use this tool called JotX, I'm not sure. But this is one of a few different tools that you can use to decompile DEX files, which is basically an APK file is a collection of different DEX files, and you can decompress those into Java, and you can go ahead and look at the source code of the Android app. Sorry about that.
So you're you're basically reverse engineering the source code of the application to look for secrets that weren't properly generated or hidden. that like are basically either
Yeah.
that are basically hard coded into the script, that where if anybody bothered to just reverse this and look at the raw code, they would be able to see that there were secrets stored, basically easily accessible to anybody who took that step.
Yeah, and for this case, definitely we have to look at the source code and see where that that key is stored directly as a string in the code. But this is a fundamental skill to exploiting, is being able to reverse engineer the source code and seeing where any errors might lie. And if we have time, we'll explore some of the more advanced exploits where we do have to actually kind of dig into the source code and try to interpret what the app is doing wrong.
So in the real world, the most likely thing that this would probably be would be like an API token, or like something else that allows you to like make like calls to the database that you're not supposed to, and maybe scrape information that you're not supposed to. Would be the way that like, because I actually understand that like I think one of the most recent attacks that was kind of publicized was directly related to them publishing secrets by accident on GitHub, and then people using those to go in and scrape everything. Your screen is also a beautiful rainbow at the moment. I'm not sure what happened.
Oh, is it? To me, it just looks white. So I'm sure
it's definitely OBS, but
okay. Is it still messed up?
It's a little bit, but we'll work with it.
Okay. I'll try to be more descriptive. Okay, cool. But yeah, and like that's a perfect example, API tokens, because those are often really long, and the easiest and laziest way to do it is just to save it as a string in your code, and then reference that variable so you don't have to type out that whole string. And if you're getting apps from a shady developer who's doing like really bad techniques like that, then yeah, this is one way to. This is an example of this exploit. So like I was saying, JotX basically converts the APK, which is the compiled code that the phone can understand, back into a human readable Java code. And JotX has a GUI which works on Windows, which is amazing. Oops. Why isn't it coming up? Oh, okay. Sorry. It's so embarrassing.
That's okay. No, this is really cool though, because I feel like we're starting to get into some of the stuff that people who really do this for work actually like have to go through almost as a checklist when they're going through like a new APK file or like something that they want to like investigate.
Yeah. So I accidentally, when I was clearing up my computer to get ready for this, I accidentally deleted the GUI version of JotX, which is the one I wanted to show off.
So well, it looks like now you get to show off how to install it.
Yeah, that's exactly. So you can just go to JotX, and then I googled JotX GUI, and we can just download. I'm on Windows, so I'm just going to download the exe, and it's so easy. You can just download the source code and compile it, but the exe is available for you if you want to do it on Windows, because compiling source code on Windows is really annoying a lot of the times. But if I was on Linux, then I think it's using Pac. I think that's the what uses. Yeah, on Linux you use that's Arch, Pac Linux. But if you're on Mac, you can just use Homebrew to install it very simply. But right now I'm on Windows, so I have to deal with this.
Great.
Okay, cool. So that's super easy. I have to tell Windows I do trust this app. And here we go. So now it's going to ask for what APK file I want to decompile, and so I have the Diva APK on my desktop, so I'm going to go ahead and decompile that. It's going to take a couple seconds, and now we can look at the inner workings of the Diva app. So we were on the hardcode activity. So if we go ahead and open, and so here's the source code for that app. As you can see, it's creating the interface first, and then...
Could you make it like substantially bigger? Because it just looks like a little scribble of intrigue.
I'm not sure how to zoom out here.
Try Command Shift plus.
That's not working.
Sad.
Yeah, and there's nothing on view too. Preferences.
Yeah.
Preferences.
For blind people.
Font.
Yeah.
Here we go.
Huge.
36.
Whoa!
Cool.
Hell yeah! That's beautiful. We did it.
Oh no! I pressed
it.
Preferences.
Well, at
I
least we know
trusted
it
the
works.
computer too much. And let's go to, what about 28? See if that's big enough.
Reasonable. Okay, that's perfect. I can
Okay,
read it.
cool.
All of our fans, thank you.
Okay, sweet. Okay, and so if we look at this code, and so this is the access function, and if it equals, so basically what it's saying, if uh, if the text that it gets when it converts it to a string is equivalent to the vendor secret key, then we'll let you in. So
Whoa.
I have a hunch. I have a hunch that the private key is vendor secret key.
I have a
So
hunch that the developer will see you in hell if you get it wrong.
so we can go back to the app, and then I have to type in vendor secret key. Then yeah, it gives me. It might be hard to see, but it did give me the access granted message. This is like kind of a dumb example, but the perfect example was like API tokens or stuff like that. And there, and like in an app with thousands and thousands of line of code, who knows what the developers could have forgot to encrypt before they actually compiled and sent out the code. So that was one simple example of hard coding.
Yeah, and again, this has to do with hard-coded credentials, hard-coded vendor keys. This comes up very frequently in, things that vendors do. So this could be how you discover an IoT device has a hard-coded vendor key, because we're not just talking about, the application itself. If that application is supplying something to like an IoT device when it's setting itself up, you could discover that all of these devices have a hard-coded password embedded in them that allows anybody who uses that vendor key to access them. And that would be a big deal and potentially a bug bounty. So I just see there's so many different applications for how you can make a little bit of money on the side doing bug bounties for this stuff, because it applies to so many to so many different things like API keys or even just hard-coded credentials for a device that an application might be interacting with.
Yeah, exactly. Like these are very like contrived examples, but it's just like to get across the point that sometimes like stuff that shouldn't be included in the code is there, and if you decompile the code, which is not that hard to do, you can just go ahead and look for it.
Yeah, that's fantastic. I think that anybody who wants to get started with these sort of things, looking into the code and seeing what's there, understanding if there's something juicy or interesting, even if you're not like a Java developer, like none of us are Java developers, and we were able to go through these like 23 lines of code and see the one that obviously seemed to relate to the login. So, if you're just getting started, this could be a way for you to punch a little bit above your weight class when it comes to looking at code that you don't quite understand, but knowing what you're looking for in terms of secrets, logins, tokens, that sort of stuff that's burned into the code rather than being dynamic or generated.
Yep. And that's a good segue, because now we're going to talk about how you might be able to find data that is saved more dynamically. So like user inputting a username and password, and then it's stored incorrectly. So we can go ahead and segue right into that.
Cool.
Okay, so now we need a username and a password. Do you have any recommendations?
Bucks, trucks, and suckers. It's
Okay.
a business idea I was going to start up. I was going to sell lollipops at truck stops.
So that's the name. Okay, what about the password?
Bucks, trucks, 69.
Bucks.
Capital
Trucks.
B, capital T.
Okay. Capital B.
Or
Trucks.
capital B, capital T. Bucks, trucks, 69.
Yeah. Capital B Bucks. Capital T Trucks.
Got it. Okay,
69.
cool. Just making sure.
Cool.
By the way, nobody take this idea.
And this is your actual password, so don't actually try this, right?
Yeah, please don't log into any of my accounts.
Okay, so third-party credentials were successfully saved. That's the message you just give me.
Good.
So now we can go ahead. Now the other ones are a little bit easier. We could just use logcat or whatever, but now we got to dig into the code and do a little bit of detective work.
So okay, in this case, the first time we found the hidden key, it was static in the code. This time, it's actually a variable the user has entered and is now actually where is it?
Yeah, that's what we're going to figure out. In this case, I'll give a little bit of a spoiler. It's saving it onto a file on the phone's memory. But let's go ahead and see how we would figure that out.
Cool.
So all of these, I didn't explain it thoroughly, but on the left-hand side, these are basically different Java classes. If you're familiar with Java, it's basically like normally in Java, like classes will be like a single function. So on this case, we'll go to insecure data storage 1. And now we can see that in the save credentials function, it's using something called preference manager. And it's saving it to this thing, whatever called preference manager. And it should be saving to something called save prefs, to string. And then it's coming into sped it. So we have an idea that it's actually being saved to some file on our computer, but we're not exactly sure where. So the first place I would check is I'd actually go into the phone now and see if there's anything that obviously Diva would be used to save files in. So to do that, we're going to have to open up ADB again. So back in my console. And then we're going to have to go on as root. So ADB is running as root. And then now we can open the ADB shell. Oh, that's right. It wasn't working earlier on git bash. Let me open it in command prompt. Oh, I can't zoom it in. Okay, so here. So ADB shell. Okay, so now we're interacting with the Android device, completely command line. Now I'm on a Windows computer, but now I'm basically, it's kind of like I'm SSH'd into the device, so I can use Linux commands like ls. So most of the stuff will be stored. Most files that the user will actually interact with is going to be stored in data/data. Sorry.
You try to execute it. Nice.
And then data/data. And then now we have all of this garbage. So
Did you just
we
say
know
Pink Ocean? There's just a bunch of random there's just a bunch of weird names smashed together.
All these weird Google names. So I don't know what all of this crap does, but we can use our friend. Come on.
It's gone.
Oh.
Sorry. No, it's gone.
I see it down there. Okay. It's being annoying.
Try pressing enter.
No, I just opened a new shell. I gave up way faster than you.
That's all right. That's okay.
ADB. Okay, so ADB shell, and then CD data. Okay, so now we can use our friend grep. So we can ls, and then pipe, and then we're going to grep for Diva, because we're looking for if Diva actually saved it within its own little Android compartment. And so here is the Diva app, so I can go ahead and change directories to this folder. And there's a couple things here. Yeah. So there's databases, which we're going to come back to a little bit later, and there's also shared preferences. So let's go ahead and see what's in shared prefs. Oh, and there's this XML file.
Hey, that's almost human readable. Let's take a look.
And okay.
What the hell?
Yeah.
That's my password. Someone could steal my whole business.
Internet to see.
Yep. Oh my gosh.
Yep. But
so for convenience, this application is storing passwords in plain text as an XML file.
Yes, which is really dumb, but developers do really dumb things all the time. Yeah, and it's accessible on the device. So using the command line makes it a little bit easier, but you could even dig around on the phone and use Android's built-in file manager, or hopefully get a better file manager app and poke around there.
It's also conceivable that if you gave another application permission to access your storage, that it would be able to access this file.
Yes. Yeah, and then they could go around and poke in there. If you do give it the privileges, they could just go see what's in there. And shared prefs is a common directory used to store stuff like this. So it's very scriptable. It could just go into every subdirectory, see if check shared prefs, check if it has privileges to actually enter it, and just copy what's in there.
Yeah, that's sketchy. I mean, because this is also talking about ways you could extract this from a user's phone. If you know that it's stored in plain text locally, then it's relatively easy to start targeting that if you know that it's worth targeting. So, if you're looking at ways to specifically go after a certain account, then knowing that the credentials are stored in plain text on someone's phone is a great place to start.
Yes. Okay. And so now we can go over an example where they store it in a SQL database instead of in plain text.
So, so those credentials are stored in a SQL database. Can you just cat that database? I dare you.
The SQL database?
Oh,
No,
yeah.
this one is. Let me see, because I did it earlier, so the database is correct. Has been made. So if we go to databases, I didn't try it earlier when I was doing the testing for this. I pulled the file out and used the SQL software on that computer to look at it. But
Oh, yeah, I bet you did, but try catting it. See what happens, coward.
CD. Huh,
Yeah.
this is not a directory.
Well, you CD'd it. Cat it.
Oh, yeah, you're right. I don't know what I'm doing. Yeah, a bunch of garbage.
Wait, is there anything human reader? No. Oh, yeah, no, that does look like garbage.
But it does give you the headers. So you did get some useful information out of this. Gives you the database headers. So you know usernames and passwords are being stored in here.
Okay, but you can't actually see the password. Is my Bucks truck password in there?
No, so this one is not in there because this is associated with a different Diva app. So let's go ahead and put your Buck trucks and suckers in there.
Let's do it.
Okay, so I'm gonna just call it Buck, and then Bucks trucks 6969, just to differentiate it.
Yeah, just keep it secure after leaking my last one.
Yeah, we gotta change it up. So now let's go ahead and really quick we can look at the source code, and I'll show to you that it is using SQL. Yeah, so early on in the source code, I see it's declaring this variable as a SQL database called my DB, which probably means like my database.
Or mobile database.
Or mobile database, yeah. So I'm gonna go ahead and look at the save credentials function, and if the user inserts it, it's going to save it all to MDB. Where is it?
Execute SQL, insert into user values. Yeah, and then it does an insert function.
Yes, so we can be pretty confident that it's being saved somewhere onto a SQL database.
So, okay, now that it's in there, can you try catting it again? Just for the sake of curiosity. Sorry to derail you, but I love catting files that you're not supposed to.
And it gives you, there it is.
So of course I'm doing this just to make a point that some XML files are very human readable. Databases are cluttered. You can grep through them or try to look through them, but in reality, if this was a normal database file that contained thousands of entries, we would have our work cut out for us to make this human readable. Just because this is so short, we can just look through it with our eyes, and we don't necessarily need to use additional tools in this example. But in a typical file you might expect like this, these databases are designed to hold lots of different things, and you can expect that there would be so much stuff in here that it really would be advantageous to be able to use the headers to do something a little bit more advanced than just trying to read the entire database manually. Nobody wants to do that.
Yeah, but that's something I didn't even think about, just catting the SQL database anyways, because it does have all these grandma using emojis stuff, but then it just right there it prints out the raw text. I can still show off how you would pull out the SQL file anyways, because that can be a useful thing to understand, is how to pull files off the Android phone.
Of course, and nobody wants to read for 12 minutes before finding, these credentials in a giant dump of as you said, grandma emoji text.
Yeah.
So it's much easier to use a standard SQL way of pulling this information out.
And often there's going to be other columns that are associated with the SQL database that have parameters we don't really understand, and so we don't know which one's the password and which one is which. In order to pull these files out of the database or off the Android phone, we're going to have to open a new instance, a new terminal window, because right now this terminal is basically the phone, if that makes sense. Like I was saying earlier, it's we're SSH'd into the phone, so we can't pull the phone, or we can't pull files from the phone onto the computer if we're in the phone. So I'm going to go ahead and open up a new terminal window, and we're going to use the ADB pull. I'm going to make sure this is right. Okay, so we're going to use ADB adb pull, and then we're going to need the file directory of the file that we want. So I'm going to go back to this window, and I'm going to type in pwd, and so it's /data, or I can just copy it, actually. I'm going to do that.
Okay, cool. So this is just like instructing it to do a file copy operation to the computer from the phone.
Yeah. And that's not cooperating. So data /data//car scene .diva /databases /IDs 2.
No such file directory.
That's really weird. Let's get that another space. PWD databases. I think I typed it in right. Assume Diva /databases IDs 2. Yeah, that's weird. This is definitely the command. Let me try it out. Sorry about that.
That's all right. It happens. This is the point of doing live streams. We try. Okay.
Here we go. Okay. I wasn't supposed to include the first /. My bad.
Computer science, fun.
So now we have this IDs too. My computer, and I can show you. It's even on my desktop. Wow, look at that.
Hey, what does your computer try to open it with by default? I'm just curious.
Let's see. It's asked me. Let's open it in my PDF program.
Okay, that's really funny.
No.
I'm sure we can. I'm sure we can blur that.
It just says no.
Oh. It's just like no. Sorry, we fucked up. This is like not something we can even open. We shouldn't have said we could.
Okay. So right now, if I wasn't cheating a little bit and I didn't already know it's a SQL database, we can verify that it is a SQL database by using the file command, which should come default with Linux, and we can see that it is a SQL database.
Cool. All right, so that's a good way of just verifying whether something you have a hunch is a SQL database it actually is if it doesn't have a file extension.
Yes. So now I can use SQLite, SQLite 3 to open IDs 2. Okay. Git bash is not behaving how I want it to, so I'm going to use.
I thought that was the entire feedback. I thought it just was just
yeah, no. I don't know what's wrong with Git bash right now. Normally it does so well. Okay, so I'm going to use SQLite 3 to open IDs 2. There we go. And we can use the command select. Sorry, I'm so ignorant on SQL. So I just know this command works, and it gets you all of the data from this database, and you can see. Yeah, it has the username and the password. This was from a test I was doing earlier, and your new password is now leaked. Sorry, Cody.
I believe I hate it. I believe if I remember from just like dumping SQL databases that you just do oh God, what is the command? A select star from star.
I could try that too. So
I just want to see if that
I'm
works.
assuming the star is still like
any
like a cat. Yeah.
Oh yeah, it hates it. Okay, I guess you can't do that.
Yeah,
Perhaps
I'm not
I
sure.
was wrong.
But I'm not sure what my user is. But so that was the same exploit, but instead using a SQL database, and it just showed off how you can pull files off of a device, which can be very useful. One of the last things I can show off is SQL injecting, and so this is being able to. I don't understand all the black magic going on, but it's basically inserting some text that the SQL will interpret as a command, and it allows you to see, like, it dumps a huge amount of information onto the screen.
I'm
So
obsessed with
input.
finding that SQL command, by the way. While you do that, I have to find the dump table command because I used to know it so well.
Okay, while you can do that, I'll go ahead and introduce this. So basically, what this section of the app is doing is it's allowing the user to input their username, and if they correctly input a valid username, it returns some information associated with that username. Obviously, this is like a very simple example, and you'd want some kind of identity verification associated with that username. But the SQL injection command will allow us to trick SQL into returning us every line in the database.
Ah.
Yeah. So if I go ahead and enter a name to search, I'll just try my own name. It searches and nothing comes up because that username is not found inside the database. But I'll put one that I do know is in there. So admin is in there. If I search it, it basically returns the username, the password, and the credit card information.
What? Okay, well that's not good.
Yeah, that's not good. This is like a dumb app, but it does show off how we can interact with the device.
So the error here is that like at least just in the brief demo is that like if you put in a user that you know is there, the error message contains too much information.
That's how this part of the app is supposed to work. If you put in the correct username, it is supposed to return you that information. But what is wrong about this app is, say I put in like a quotation mark, which is used for like SQL syntax, and it should not be considered a valid character in like either a name or like a username in a SQL database. So if I search that, it's still including that as an actual, that quotation mark. It's thinking of it as it could be a real possibility, when in reality it should check it, see that it's just a quotation mark, and no, that is not a valid thing to put. So instead, we can. So here, I need a notepad. But basically, we're inputting the database, and it gets inserted in between some quotation marks. But if we give it, if we can somehow trick the SQL database into thinking whatever we put is a valid response, then it's just going to return everything. So one way we can do that is sending a statement that reads as true. So if you can see, is this big enough?
Yes,
I just have
two.
So basically, whatever we're inputting is going into these quotation marks. So the reason that the SQL database shouldn't allow you to put in quotation marks as a valid username is if I just put in 1, this is going to screw up the command, because basically the code is going to look at this as the inputted text, and it's going to ignore this last quotation mark, which is that. So now if we put in a statement that will read to the SQL database that is true, then we can get the app to return us all that information, because basically it thinks every input is valid. So one way we can do that is, like, one example is something like 1 doesn't equal 2, or like 1 equals 1. So we can do 1 doesn't equal 2. And that is something that will always return true. But the problem with that is this, because we haven't added any quotation marks, this is actually being inputted as a name. So if we put a quotation mark after the 1, and if we put a quotation mark before the 2, it's actually, the SQL will literally check, does 1 not equal 2? True. Okay, return the user this line. We'll go down to the next line. Does 1 not equal 2? True. Okay, return it to the user. Let's go to the next line. And you see the point. I'll keep doing that for the entirety of the database. So the reason I showed it off with that is because the input text kind of looks a little weird otherwise. So we're going to put in the 1 with its second quotation mark, and then we're going to put in the not equals, and we're going to put in a quotation mark for the 2, the forward quotation mark for the 2, and we're going to search. We sent it a true statement, and as you can see, it returned us, I'll keep pressing it so it stays on the screen. But it shows us all 3 members of the database.
Because it keeps returning true over and over.
Yes. So the problem with that is, I'll go ahead and open the source code. This was validity. Let me find it. But basically, the problem is that um, the code isn't actually validating that here it is, SQL injection activity. The code isn't actually validating that what the user input is a valid SQL input. And it's allowing us to get tricky with those quotation marks and forcing SQL to literally analyze the text that we analyze as if we had access to the raw code, which is not something we should do. So
Right. So rather than evaluating this within the function it's properly supposed to, we are now adding, effectively on the fly, adding code to what this is executing by tricking its lack of input sanitization.
exactly. And like these are like injection exploits are some of my like favorite things to see once like somebody figures it out. Because it just feels so wrong, just like putting raw code into like a user input box like that, and then having it actually work, and it just shows you like the facade of what's going on in front, and it's actually just all freaking code. It's all dumb code, you know.
Yeah, and frequently it's like very short. And this is something that also scales not just to, like an Android application. This is also something that's very much the case on just web applications as well.
Yeah, yeah, and like there's plenty of different examples of exploits like this. Very common, and they can be tricky to find because if the developer isn't being zealous about validating all user inputs, stuff like this can sneak through.
Yeah, I love that because it was one of the first things we were taught was like doing sterilization and doing like making sure that any input that the user puts in cannot be run as code. And I remember that like, yeah, if you fail to do that, then you can really get taken for a ride by what the user puts into the box if it's interpreted and executed within your code.
Mm-hmm. Yeah, and like one thing I've also studied and I've talked about on Nullbyte is using command injection to play around with like a gateway. So you can send the gateway different different messages that is actually like code, and you can basically control certain aspects of the router, and you can basically take over the network by sending it these random messages that look like, well, it looks like code, but it's not an actual message. It's not an actual like network package.
That's super cool. Maybe maybe you should show that off sometime because that seems really interesting.
Yeah, we can talk about that another week. It was fun.
Cool. Yeah, so we've gone through a bunch of the different Divas apps. How many are there total again? Was it like 12 or something like that?
There's 13. A lot of them are riffs on others. So like these three are, so we went over the first two insecure data storages, but these two are basically just variations of that. But yeah, there's a bunch of different ones.
Cool. Well, I think that this is a great series to pursue for, again, anybody who wants to get into like bug bounty hunting or like making a little bit of money on the side, looking for these sorts of super common vulnerabilities in everything from web applications to Android apps. And being able to emulate this on your own device really seems like it brings it home for anybody who wants to get started with this without making a huge investment like buying a bunch of Android phones. So, I mean, if people are really interested in this, if our audience likes it, I would love to have you come back and maybe go through some of the additional challenges and just show people how to get started using the right tools to, identify some of these. Because watching you go through this challenge is actually really fun, and I'm learning and refreshing myself on like SQL databases and like, knowing that you can do this stuff so easily is really cool for any beginner who's been holding back on learning about this sort of stuff when like, clearly if they have a laptop that can support like creating one of these virtual devices, they could get started tomorrow and really start learning some of these things and seeing, the thrill of grabbing that password out of a database file or something yourself.
Yeah, and like obviously you're not going to be able to get the exact source code from every Android APK file, but it does like kind of train you for if you were using like a reverse engineering program, and it allows you to it puts you in the right frame of mind of looking at like a bunch of code, and it gives you some like red flags to look out for if that makes sense. Like it gives you some like common mistakes that can happen, and it just gives you some practice, and so you know where to start to search if you're looking at like a code base of like tens and thousands of lines. It gets you a good place to get started.
Yeah, I mean, frankly, it sounds like kind of a cheat sheet for anyone who's doing pen testing for something like Hackeroni, who wants to just be able to look through the most common ways they can get an easy payday working with, somebody who's developing a mobile application and wants somebody to take a look at the security of it. So, having more people understand these very basic steps that you should be taking to just go bit by bit by bit and look for the weakest points. Like, if you know that very frequently these are going to be the issues that you're looking for, it's great to have this testing ground where you will not get in trouble for doing it. You can try out all the tools and nobody's going to write you a cease and desist or otherwise mess with you while you're learning this. When you get into the actual game and you start making money on it, then it's kind of a different deal. But again, working with one of these bug bounty companies is a great way to kind of have a mediator in there, making sure that you don't accidentally spook someone whose app you found a serious mistake with.
Mm-hmm. Yeah, and like this is so much of pen testing is that skill exactly what you're talking about. Being able to look at a code base and really interpret it and understand it, and then to work with developers. And it is like some people that's all they do, and they don't have to work every day to do it. They just if they get enough high profile ones, I couldn't pay most people's salaries,
Yeah, and it's built-in training as well. You get to practice this stuff and you get to see real-world examples. So if anybody's looking at doing bug bounties and stuff, again, highly recommend getting started with learning these sorts of vulnerabilities. This is how you guys get paid. And even if you're a developer, learning some of these things, I think, will really teach you where you can get caught making mistakes that can have critical impacts on the people that are using devices. So, I mean, there's also tons of other uses for Android Studio besides the one we showed off. Like, obviously, this was not what Google intended, like when, they made this freely available to the public. And that's good, because I was even asking Nick, if there was like an app that I wanted to run on my computer, but it's only available to run on Android. Like, I just got a drone and I wanted to use the DJI Fly app. Like, is it possible to maybe run an app and have it be on my computer and connect over USB? And it turns out it might be. So like hearing about these possibilities where you can use this as just a tool for anything Android related, including loading vulnerable applications that the community has created and learning about how to make money hacking. I mean, it's a really excellent tool that I'm not sure a lot of people are aware of is out there and free to use, and they could really benefit from if they want to take some time over the weekend or something to learn a little bit about SQL injection. I mean, at the very minimum, you're going to come to your next hackathon with a ton of new skills. So, if you're doing a CTF or something, I feel like this is great practice, and it's also nice to have Nick here, like guiding us through like the right way to do it. So yeah, I would love to have you back on to like show maybe some more of these challenges, especially if there's demand in the comments. Maybe we'll do it sooner rather than later, because this was super fun, and like I feel like I just refreshed myself on a lot.
Yeah, I like it because you do have to know at least a little about a lot of different parts of computer science in order to adequately be able to like find the different bugs and see how to exploit them. But I mean, that might sound like there's a high barrier to entry, but it allows you to learn so many different skills so fast, especially if like if you're really interested in like seeing how this stuff works. I think it's just so cool to be able to like pull back the veil and see all the code that is like running under the hood.
I agree. And yeah, I think this is, it's still accessible because it introduces beginners to like the core things that you need to know in order to test an application. And that I think is just like a really great stumbling block to get people over so they feel comfortable trying this stuff out on their own and maybe analyzing their first APK and seeing what's in there and seeing if they can identify any of the things they've been taught to look for using this vulnerable application. So thank you for sharing this with us. I really feel like a lot of people are going to benefit from it, and that this is probably going to be one of our more popular episodes just because of like, people can turn around and make money from doing this legally and safely. And I think that's super cool.
Yeah. And like, I think like 80% of the world has Androids now. It's like, it's by far the most popular, like daily used operating system in the world.
Yeah, and this also seems like it's a good gateway to analyzing malicious APKs as well, if that ever becomes your job.
Yeah.
Cool. Okay. All right, well, that's going to be our time for today. If you want to check out Nick, he's going to be on our new Hackbyte show on Hack5, and I believe you can also check him out on Twitter. Is your handle
Nick
just
Godshall. Yeah, it's just Nick Godshall.
This is what I'm saying. Just full legal name as your handle on Twitter. Go all out. Yeah, you can also find Michael as like the underscore Hoyd one or something. So also his full legal name. We changed it just for the show.
I mean, it's easier when like 1,000 people in the whole world have your last name, though. So
this is true. Yeah, I imagine it's easier to get in there with that. All right, well, thank you everyone for hanging with us in the chat today. Hopefully you guys learned something. I definitely did. And if you want to see more Nick, please make sure to like, share, subscribe, so we know that you want another one of these episodes, and we'd love to keep doing them. So Android hacking is super fun and cool. And if you want more topics like this, just shout out in the chat, and we will make sure to make them happen. Nick, thanks again, and we'll see everyone next time.
Thank you. See you guys.
Bye.